All right, the next thing we're going to talk about is reference angles. All right, so a reference angle is reference to the x-axis. So what I'm really looking for here is on this x-axis, I know that this is 0 degrees or 0 radian and 360 degrees or 0 radian and 2 pi, right? I have both of those options here. Or on this side, I have 180 degrees or pi is what I'm looking at. So whenever I have a reference angle, I am always referencing back to the x-axis. A reference angle is also always an acute angle. So it's whatever it takes, depending on where I am. If I'm up here, it's this angle. It's not the whole thing going back over here to get to that. It's the acute angle that's, pardon me, closest to that x-axis. Over here, is it up or is it down? It's just whichever acute angle gets you closest to that axis. All right, that's called a reference angle. So let's take a look at some. We want to find the reference angle. Whoops, oopsie daisy. I missed a few letters in there. Let's try this again, shall we? Okie doke. So the first thing I have is 218 degrees. Now here's what should be going on in your head is you need to be thinking, which quadrant am I in? Think, which quadrant am I in? That's what you're thinking. Which quadrant am I in? And then decide how to get back to that x-axis. So for 218, if I'm looking at my angle here where 218, I know this takes me to 180. This is 270, so it has to be between in this one for that 218 degrees. So it's going to be approximately there because I know that this one's 180 degrees and this is 270 degrees. Do you see how we're getting there? So all the way around is going to be 218 degrees. So my reference angle is going to see what it takes to get back to that x-axis. And honestly, you're just looking and seeing how am I going to get there? So if I have 218, I'm going to subtract 180 off of that, and that's going to put me back at that 38 degrees. So my reference angle here is 38 degrees. Do you see our game now? Okay, so yes, my actual angle is much bigger, but I'm trying to figure out that reference angle. What's it going to take to get back to that x-axis? That's the whole thing that we're doing. All right, here, try another one. What if I have 1,387 degrees? Now that's way outside of our even 360, right? So what do we have to do? How do we bring that back into 360? What's that called? Oh, coterminal, baby! Look at this, previous information into the current lesson. I love it. So we have to figure out our coterminal angle before we can even figure out the reference angle. So how many of those swing arounds are we going to have? Let's try 3. 360s. Plug that in and what do you get? Oh, good. We're good. 307 degrees. Okay. So this is our coterminal angle, right? I can't even read that, so I doubt you can either. Coterminal angle. So that's my coterminal angle. So with my coterminal angle, then I look at my coterminal angle and say, okay, where is that little stinker? 307 has got to be way over here somewhere, right? I'm going to say there, 307 degrees, about that. So what I want to try to figure out is what is left over. What is this reference angle? So what do we do in order to get that one figured out? Yep, you subtract it from 360. So it's really just kind of number sense and trying to figure out what's it going to take. So I have 360 minus 307, and that's going to leave me with 53 degrees. And that is where I'm going. Do you see? So how can I get closer? Is it past 180? Then we're going to go with that, right? So how do I look at this in order to get it to where I need it to be? So if it's up above here, then I'm going to take 180 minus this value, and that tells me the difference. What difference am I going for? I want this difference here, so then that's how I can pull that off. Well, I can have degree, but not everything's in terms of degree, is it? What if I get a little radian action going on? 5 pi over 6. Where is that? 5 pi over 6. Yeah, it's not quite to the 180 degree over here, but it's right in this mess. 5 pi over 6 is going to be that angle. Well, if I'm taking it all the way to pi, then how do I get there? Good. So pi minus 5 pi over 6. Well, whenever I'm looking here, I have to get my common denominator. So then that's going to leave me with pi over 6 as that reference angle. All right. Whether it's degree, whether it's radian, it doesn't matter. You're still just going to try to find that way back in order to get there. All right. Okay. Now, you know I'm a fan of the unit circle. I'm going to talk to you this next go around here about a couple different ways that we're going to work this next problem. So here's our first one. Here's example 5. I'm charged with find all 6 trig values of 210 degrees. Oh my goodness, I did that twice now. My two words are meshing together. Find all 6 trig functions. And I'm looking at 210 degrees. All right. So 210, that's greater than 180. So if I'm looking at this, I know it's got to be over here somewhere. So that's my 210 degrees. So I take 210 minus 180, and I come up with this 30 degrees. And what do we know? I pulled up our unit circle this time because look at what's happening here. If you know that this reference angle right here is your 30 degrees, you're 30 degrees off of this, right? So I'm looking at this 30 degrees off of this. That's my pi over 6, my 30 degrees. I have these same values. This is all symmetric, right? This is all symmetric. So you can go through here, make your right triangle, have your nice right triangle that you're going for, and be able to work that out, right? Or you can look at this and you say, okay, well over here, I know that my values are square root of 3 over 2 and 1/2. Because my x is negative, then I can go from there. This is why I like the unit circle. So I can just look right at my unit circle, look at that 210. It's nice to see this reference angle because then it tells me which one I'm going for. If you know your first quadrant and you know this is 30 degrees out for that reference angle, you automatically have this. Knowing which quadrant it's in tells you that those are negative. I don't think I put a negative. Oops. On that y. That's my bad. You guys are probably hollering at me about that. All right. So sine of 210, cosine of 210, tangent of 210, cotangent of 210, secant of 210, cosecant of 210. We're just going to use what we know. Your sine here is going to be your y values. So we've got negative 1/2. Your cosine is your x values. So negative square root of 3 over 2. Tangent is sine over cosine. So this is going to be a negative 1/2 divided by negative square root of 3 over 2. You can see that those 2's cancel. Negative divided by a negative is a positive, and I'm left with 1 over the square root of 3. Now, I'm okay if you leave it like that, all right? Or you can divide that out. That's your choice. To be square root of 3 over 3, I don't care. I'm okay if you leave it the other way. Cotangent, it's nice, in my opinion, it's nice to leave it here because as soon as you see cotangent, what can you do? I don't have to mess with this. I go straight to just the fact that it is the square root of 3. Secant, this is the reciprocal here of cosine. Oops. Is my secant a reciprocal of cosine? So now I have negative 2 over the square root of 3. And again, if you leave it like that, I'm on board with it. If you have to rationalize the denominator, then do it. But I'm okay with leaving it all like this. You get into your upper math and they leave it like this all the time. Cosecant, I'm just swinging around that sign. And that gives me my negative 2. All right? So working these over, you can just use your unit circle. You can work with your right triangles. That's your choice. When I'm talking about these special angles, if it is an angle that actually shows up on here, if my reference angle or one of my special triangle values, then you can just go straight to your unit circle and come up with it that way. All right? Okay, check this out. Let's just do a couple of just rando things. So example 6 says, find the exact value. So if I'm finding the exact value here of the cosine of negative 240 degrees. If I'm looking at the cosine here of negative 240, then I have to make that positive. So I have negative 240. I'm going to add 360 to that. And that puts me at 120. Or I can look at this. I'm telling you, I love this unit circle. I'm looking at 240 is right here, right? If I take this all the way around. That means if I'm going negative, I'm going in the other direction. And that's how we get up here to the 120. And those are my values. Negative 1/2, square root of 3 over 2. So if I want to find the cosine of this, that's going to give me that negative 1/2. Oops. So the cosine of negative 240 degrees is that negative 1/2. Honestly, if you have your unit circle, you get those if it works with those common angles. As long as you have those common angles, then you're good to go. All right. If you don't have your common angles, then you have a calculator. So for my first one, I want to look at the cosine of 49 degrees and 12 minutes. Now, we're not going to have this all the time, but to have this cosine, you literally just take your calculator and you plug that in. When you're plugging that into your calculator, then you have 0.6534. We'll just take it to the 4 decimal places. Bam, then you're done. What happens if I have something like cosecant? Cosecant of 197.977 degrees. What do you know about cosecant? Yes, it is. So this is the reciprocal of sine. On your calculator, you have sine, cosine, and tangent. You do not have secant, cosecant, because you don't need it. They all refer back. So when you're doing this, you literally just plug in 1 over the sine of 197.977. Put that in the denominator. whammo jabammo, and you get negative 3.24007, so negative 3.24. We'll do 0, 1, because it's 007. Just use your calculator. If it's not a common one, you can get right off the unit.